Do you see my screen?
Yes, sir.
Okay. So today we are going to discuss correlation and regression analysis. Just a moment, let me write down. Correlation. क्या हुआ? हाँ. Correlation and regression analysis. What is correlation? Let me write down. Correlation is the measure of the measure. I'll explain it line by line. The measure of the degree of relationship. The measure of the degree of relationship between the values of x and y. The measure of the degree of relationship between the values of x and y. X and y. So that is known as correlation. Now, what does mean by that? You have some set of two-dimensional data. You plot it and observe what is the degree of relationship between the values of x and y. So these are the two-dimensional data. One side is x-axis, another side is y-axis. For example, suppose you want to see the relationship between height and weight. Height and weight somehow is related. For example, what you do from a population of 100 people, what you do? So suppose minimum weight is, let's say, 40 kg. And so which is denoted by x-axis, and suppose maximum weight is, let's say, 90 kg. And from a population of 100 people, you measure their heights. So this side is height, y-axis, and x-axis is weight. So what you do, of these 100 peoples, you collect the data, their height versus weight, and you try to see if there is any relationship between the values of x and the values of y. In other words, is there a relationship between height versus weight? So normally it is same. There is a relationship between height and weight. जिसकी height ज़्यादा होते हैं normally उसकी weight उतना ही बढ़ते हैं. It is not exactly true, but there is a trend. So how to measure that relationship? So that is given by this correlation. Correlation will tell you how much x values and y values are related to each other. Okay, that is correlation. And what is regression? Regression, this is the measure of how well a linear, the measure of how well a linear or any other type of equation, any other type of equation explain the relationship between x and y. Other type of equation explains the relationship between x and y. X and y. Now, do you recall what was car fitting? Do you recall what was car fitting? Car fitting and this regression is somewhat related. Do you recall what was carb feeding? In carb feeding, suppose you have a two-dimensional data points. So these are the two-dimensional data points. And what was the problem in carb feeding? You have to find a carb which will be representing these data points in a most suitable way. Is not it?
Yes, sir.
Now, in carb feeding, we assume something, we considered something that X values are करेक्ट, एक्स वैल्यूज में कोई एरर नहीं है, ऐसे एज्यूम किए थे या नहीं किए थे? कार
Yes, sir.
फिटिंग में हम लोग एज्यूम किए थे कि एक्स वैल्यूज में कोई एरर नहीं है, वाई वैल्यूज में एरर है। तब हमने क्या किए थे, एक कार को मान लिए थे, सपोज दिस इज द कार विच इज रिप्रेजेंटिंग द डेटा इन मोस्ट सुइटेबल वे। और हर एक डेटा के लिए हम लोग ये जो डिफरेंस है, वर्टिकल डिफरेंस, इस डिफरेंस की स्क्वायर को लेके हम लोग एरर फंक्शन को बनाए थे, हाँ या ना?
Yes, sir.
हर एक पॉइंट पे डिफरेंस निकालो कार्व से, तो दैट इज द एरर इन दैट डेटा पॉइंट, and then you square these errors and add it. That was the S. What was S? Total error. Total error was, suppose you are fitting the curve y equals to x plus b. So what we assume, that we assume the x value is correct. X value is correct. Only y values may some amount of error is there. Then what was a summation I equals to 1 to n yi minus axi minus b whole square. This was total error. Okay, then what we did, we use the analysis calculus to determine what is the most suitable value of a and b. Most suitable value of a and b by considering del s upon del a equals to 0 and del s upon del b equals to 0. Now in regression analysis, both are having some amount of error. आपको कुछ पता नहीं है कि which variable is correct and which one is having some amount of error. So you cannot treat in this way. So depending on your choice, you will get two line of regression. You have some set of data points. For example, if you have this kind of, suppose you have this kind of data, then depending on your choice, you will get two straight line. Whether you are calculating the total error by considering the vertical gap or vertical error, or you are considering the horizontal error. You are assuming that y value is correct and x value is somewhat errorful. So depending on your choice, whether you are considering x value is correct or y value is correct, you will get two line of regression in most of the time. So these two lines, they are called line of regression. Now they will be coinciding when the correlation, you see that correlation here, when the correlation between x and y is exactly equals to plus or minus 1, then these two lines will be coinciding. I'll be explaining in details, don't worry. And if the correlationship is 0 or any other value from 0 to 1, not exactly 1 or plus 1 or minus 1, if it is any other value from plus 1 and minus 1, then you will get two different line which will be representing the data in most suitable way. It will depend which, along which axis you are calculating the error. Are you measuring the vertical distance or you are measuring the horizontal distance? You are assuming x value is correct or you are assuming y value is correct. Is it okay? So first we have to understand how to find the co-relationship, the measure of the degree of relationship between values of x and y. You have two-dimensional data. Sometimes data may not be two-dimensional. Data may be higher dimensional. For example, production of crop, production of paddy, somewhat is related to the total rainfall, the temperature, and the quality of the soil. So you see the total amount of paddy is depending on rainfall, total rainfall, the soil quality, and temperature. So total paddy, that is depending on those three variables. So in that case, you will get multiple linear regression or multiple nonlinear regression, depending on your choice. You will decide which variable you want to represent with respect to the other variable. Depending on that, you will get the multiple linear regression shape or multiple nonlinear regression shape. You have already solved one problem in some of the assignments. Such kind of problems were there. So how to find the correlationship between two-dimensional data? You have two-dimensional data. How to find out the measure of the degree of relationship between x and y? So for that we need scatter diagram. Scatter diagram means what? You consider the you consider the two-dimensional data and plot it in xy plane. जो डॉट्स आपको मिलेंगे सारे डॉट्स को एक साथ कहते हैं स्कैटर प्लॉट. जो अभी हम लोग किए हैं, these all are scatter plot. You plot the two-dimensional data in xy plane. So how to measure the correlationship between x and y? So that is measured by this number rxy. This is called the correlation coefficient between x and y. What is that? R of xy is equals to 1 by n summation I equals to 1 to n xi minus x bar yi minus y bar by under root 1 by n summation xi minus x bar whole square into 1 by n, just a moment, 1 by n under root 1 by n summation I equals to 1 to n yi minus y bar whole square. So you have n data points xi, yi, I equals to 1, 2, 3 up to capital N. Then the correlation coefficient of this data, how they are related, that is represented by this number R of xy. It is called the correlation coefficient between the variable x and y. It is given by this number. In short, it is cob xy, covariance between the variable x and y, by sigma x and sigma y. Standard deviation of the x values of the data, standard deviation of the y values of the data, and the numerator is covariance of x and y. So cob of xy, this is 1 by n summation I equals to 1 to n. I'll explain it to you. Xi minus x bar into yi minus y bar, and sigma x is sigma x square equals to 1 by n summation xi minus x bar whole square, I equals to 1 to n. This is variance of the x values of the data, and sigma y square, variance of the y values of the data, is again 1 by n summation I equals to 1 to n yi minus whole square. So these are the values. Okay, by this number we represent the degree of relationship between x variable and y variable. How? Let me tell you. What is x bar? X bar is the mean of the x values, y bar is the mean of y values. So let me write down. X bar sorry. X bar is the mean of x values, and y bar is the mean or average of y values. Okay, and by this number rxy we determine the degree of relationship between x and y variable. Kaise? Okay, let me tell you. So suppose, how do we end up with that formula to determine the degree of relationship between x variable and y variable? So suppose this is x axis, this is y-axis. Okay. And these are the data points. Two-dimensional data points we have obtained from some set of population, some set of data points there. So this is the set of the data points. Okay. Now what you do? So right now you do not understand what is the relationship between the x values and y values. So how to determine if there is at all any relationship between x values and y values? So पहले क्या करेंगे, इसकी मीन निकालो. So suppose mean is at this point, x bar, this point is x bar, y bar. Okay, these two data. Suppose they are the mean. Okay, we know the x values. So this point is x bar, y bar. Just a moment. So this point is x bar, y bar. This dot. Okay. Now what we are planning to do, shift the origin to this dot, orange dot. What you do, you use some translation. So what will be the translation? That origin will be shifted to this point x bar, y bar. Right now this is the origin. Oh, how can we shift the origin to that point x bar, y bar? What will be the translation formula?
X to x plus
X dash
x.
new x values with respect to the new coordinate axis is x dot. Xz will be what? Xi minus x bar. Okay. And y dot is what? Y dash is the y values with respect to the new y axis. So y dash will be what?
Yi minus
Yi minus y bar. So now what you are doing, you have shifted the origin. You have shifted the origin to this point. So this is the now the coordinate axis. This is x dash, new coordinate axis, new x axis. This side is new y axis. So if you take any point x dash, y dash, if you take any point with respect to this coordinate axis x dash, y dash, when this will be greater than 0, their product x dash into y dash, when that will be greater than 0. If they are lying in first quadrant or third quadrant with respect to the new coordinate axis, yes or no? If the data point x dash, y dash is this dot, then x, y, their product will be greater than 0. Or if the data point x dash, y dash is in third quadrant with respect to the new coordinate axis, then their product will be greater than 0. Okay. And when their product x dash, y dash will be less than 0, if they are lying in second quadrant or fourth quadrant with respect to new coordinate axis. Yes or no?
Yes, sir.
So this product x dash, y dash, that is greater than 0 if x dash, y dash, that point is belonging to first quadrant or third quadrant with respect to new coordinate axis. And when it will be x dash, y dash will be less than 0 if x dash, y dash belongs to second or fourth quadrant. Now what about this number? You keep on adding I equals to 1 to number of data points xi dash into yi dash. जितने भी डेटा पॉइंट आपको मिले हैं with respect to new coordinate axis, for them you calculate this sum. You calculate this sum. So if this sum is greater than 0, what is your conclusion? From which quadrant to which quadrant there is a trend? There will be a relationship, there will be a curve from which quadrant to which quadrant. If sum of all the data points, the product of sum of the all data points with respect to new coordinate axis is greater than 0, then from which quadrant to which quadrant there will be a trend from Trend is from third to first or first to third quadrant? Yes or no? Trend is from first quadrant to first quadrant to third quadrant or third quadrant to first quadrant? Yes or no? Hi, Anna. Similarly, if summation I equals to 1 to n xi dash this product is less than 0, then the trend is from which quadrant to which quadrant?
Second to fourth or fourth
Second
to
to
second.
fourth. And if this sum is 0, then what will be happening? Summation I
No
equals
trend.
to 1 to n xi dash yi dash. If this is less than 0, then trend is from second to fourth quadrant or fourth quadrant to second quadrant. Okay. What will happen if this sum is equals to 0? What can you say? What is the trend? No trend is there. All the data are equally distributed with respect to the mean position. Yes or no? If the
Yes, sir.
sum is 0, I equals to 1 to n xi dash yi dash equals to 0, what does mean by that?
There is no
All the
trend
data points are
among
equally distributed with respect to the mean
mean position.
So expression, this expression gives crude measure of relationship between x variable and y variable. Now it has some drawback. This formula. So what is this? If you replace the values of x and y, what is this? Just a moment. हाँ अभी क्लास में आपको बाद में फोन करते हैं. हाँ. So what will be this formula? If you replace the values of x and y, this is becoming
Xi
y
minus
equals
x
to
bar
1 to n xi minus x bar into yi minus y bar. Now it
y.
has some drawback. This measurement should not be depending on the number of data points. How many data points are there? It should not be depending on that. Okay. So for example, if summation xi dash yi dash for some set of data points it is coming 8, and for another set of data points it is suppose it is coming, let's say 100. So does that mean that relationship in second set of data points is more intense compared to the first set of data points? It is not like. It's not like. So it should not be depending on data points. So that is why we are dividing it by 1 by n. तो देखो जो कोरिलेशन कोएफिशिएंट का जो फॉर्मूला था ना, ऊपर का पार्ट आ गया, न्यूमरेटर की फॉर्मूले आ गए. 1 by n summation I equals to 1 to n xi minus x bar yi minus y bar. हाँ या ना?
Yes, sir.
Now how do we get, why do we use this denominator values sigma x and sigma y? Now suppose it should be unit independent. Suppose the x value is given in kg and y value is given in centimeter. So how to interpret the data? This value should be, this measurement should be independent of the units. So that is why we are dividing by the standard deviation. We are dividing by the standard deviation. What is standard deviation of x values? 1 by n under root summation I equals to 1 to n xi minus x bar whole square. Okay, this is the standard deviation of x values. Standard deviation of y values will be 1 by n summation yi minus y bar whole square. So this is known as correlation coefficient of the data points. It is cob xy, covariance of x and y in short, by sigma x, sigma y. Standard deviation of x data into standard deviation of y data. Is it okay? How do we get this value rxy? So that tells you how the x and y values are related to each other. Now I'll prove you that this rxy is bounded by -1 to +1. Maximum smallest possible value for rxy is -1 and highest possible value of rxy is +1. And if rxy is equals to minus or +1, then the trend will be coinciding. There will be a unique trend. And if you are having any other values of rxy except for -1 and +1, then you will get two lines if you are finding the linear relationship between two-dimensional data. Remember, we are talking about two-dimensional data only. We are finding linear relationship between two-dimensional data. Okay. So I'll be deriving the result. So before we find equivalent formula of covariance of x and y. What is the formula of covariance of x and y? What is the formula of covariant of x and y?
Sir, 1 upon n
1
sigma
by
xi
n
minus
I equals to 1 to n xi minus
x bar
x bar
into yi minus y bar.
into yi minus y bar. Now, if you simplify this calculation, you will end up with this 1 by n summation I equals to 1 to capital N. This sum is not small n, number of data points. So this will be 1 by n summation I equals to 1 to capital N xi yi minus x bar into y bar. This is the another way to find out the covariance between the x values and y values. 1 by n into summation I equals to 1 to n xi yi minus x bar y bar. You see the proof? It is very simple. So this left hand side is what? 1 by n. You complete the multiplication. I equals to 1 to n. This is xi yi minus xi y bar minus x bar yi minus plus x bar y bar. Yes or no?
Yes, sir.
So first term is 1 by n summation I equals to 1 to n xi yi minus y bar is constant value, so it is coming out of the summation I equals to 1 to n. 1 by n is outside xi minus x bar is coming outside, 1 by n is outside, I equals to 1 to n yi plus x bar y bar. So what we have, what is the second term and third term? What is 1 by n summation I equals to 1 to capital N xi? That is x bar.
X bar.
And third sum is y bar. So
Y.
this is 1 by n summation I equals to 1 to n xi minus, sorry, xi yi xi yi minus x bar y bar minus x bar y bar plus x bar y bar. X bar y bar cut जाएंगे. So you are getting the second expression for cov xy. 1 by n summation I equals to 1 to n xi yi minus x bar y bar. Similarly, you have another expression for variance of x values. So what is variance of x values? 1 by n summation I equals to 1 to n xi minus x bar whole square. This is variance or standard deviation square. This is the formula for standard deviation square or variance of x. It is 1 by n summation I equals to 1 to n xi minus x bar whole square. This number tells you how widely the data points are spreaded with respect to the mean position. अगर सिग्मा x बड़ा होते हैं तो डेटा आर वाइडली स्प्रेड, अगर सिग्मा x छोटा होते हैं तो डेटा आर congested about some car, some line. Okay, so that is what sigma x square. So if you expand it the square and simplify, you will end up with this formula: 1 by n summation xi square minus x bar square. It is very easy. Similarly, sigma y square equals to variance of y. It will have this formula: 1 by n summation I equals to 1 to n yi minus y bar whole square. So if you simplify, you will get 1 by n summation yi square minus y by r square. So these are the alternative formula or expression to evaluate standard deviation with respect to x or standard deviation with respect to y. Okay.
Okay, sir.
So next is that r is lying between -1 and +1. Rxy less than equals to 1. So this is the result. Okay. So if you create a new variable from xi, yi, these are the set of data points for I equals to 1, 2 up to n. Okay. So if you create a, you know what is x bar y bar, that is the mean of these x values and y values. Okay, x bar y bar. You know what is sigma x and sigma y. Standard deviation of x values, standard deviation of y values. So what you do, you create a new variable uy is equals to xi minus x bar by sigma x, and vi equals to yi minus y bar by sigma y. So from the given data points, we have created new set of data points ui by this formula xi minus x bar by sigma x. Sigma x is a real number. Okay, vi is y bar yi minus y bar by sigma y. It is sigma y is another real number, standard deviation of y data. So what is summation ui? Can you tell me what is summation ui? Or can you tell me what is the mean of these u values? What is ui? The center of the mean values of ui data. And what is b bar? The mean of bi data. Can you tell me what is that? You substitute the values and evaluate and tell me what you are getting. What is ur? You substitute the values and calculate. What is that? It is 1 by n is outside. What is ui? Ui is xi minus x bar by sigma x. Okay. So what is that? Simplify. I'll leave some calculation. You are not listening. These two values will be coming to be 0. You do some calculation. These two values will be coming to be 0. So mean value of u variable is 0 and mean value of b variable is 0. Okay. And what about standard deviation of u values? What is sigma u? So this is again homework. You calculate, use the formula. Sigma u will be coming 1 and sigma v will be coming 1. These are simple calculations. Okay. So what is Rx? What is the correlation coefficient of u variable and v variable? What is RUV? What is RUV? So you use the alternative formula of RUV. RUV is this. You use this formula. What is RUV? RUV will be 1 by n into summation I equals to 1 to n UI VI minus UR VVAR. So this will be coming 1 by n summation I equals to 1 to capital N UI VI minus UR VVAR. Now UR VVAR equals to 0. So what is the first term? Now you substitute the values of UI and VI and simplify. So you are getting 1 by n summation. What is UI? Xi minus X bar by sigma X into Yi minus Y bar by sigma Y. Sigma X and sigma Y are two real number, so it will be coming out of the summation. Sum is from I equals to 1 to capital N. So it is coming 1 by sigma X, sigma Y, 1 by N, summation I equals to 1 to capital N, Xi minus X bar into Yi minus Y bar. So this is curve of XY, covariance of X values and Y values by sigma X, sigma Y. So RUV is equals to RXY. Correlation coefficient of U data and V data, UV data is same as correlation coefficient of XY data. If you use this kind of translation, then this is the formula. Now, what about this term? What about this term? UI square plus minus 2 UI VI plus minus, I do not need this to be plus minus, this is plus VI square. What is that? This is what? UI plus minus VI whole square. So it is greater than equals to 0. Now what you do? You add it for all the data and you divide it by total number of data. So you will be getting this expression 1 by n summation UI square minus 1 by n 2 into summation UI VI plus plus minus was there plus 1 by n summation I equals to 1 to capital N VI square. That will be again greater than equals to 0. Each term is greater than equals to 0. So if you add them, then again that is going to be greater than equals to 0. So what is first one? What is first term? What is summation I equals to 1 to n UI square? That is sigma U square, okay, plus minus 2 times what is this part? What is this part? You see, what is this part? RXY. So this is RXY plus sigma V square, that is greater than equals to 0. Now what is sigma U and sigma V? Sigma U and sigma V, that is 1. So this is 2 plus minus 2 RXY greater than equals to 0, and that is giving you 1 plus minus RXY greater than equals to 0. So that tells you that minus 1 less than equals to RXY less than equals to plus 1. So correlation coefficient of two-dimensional data is bounded by minus 1 and plus 1. Okay. Next is how to find out the linear regression of x and x on y and y on x. As I have told you, if these are the set of data points, then depending on your choice how you are measuring the error, total error, you will get two line of regression. One will be the line of regression if you measure the error parallel to y-axis, and if you will get another line if you measure the error parallel to x-axis. Okay, so here we are going to find out the line of regression of y on x. So line of regression of y on x, line of regression of y on x. So suppose you are assuming that x value is correct and y value is having error. So how you will be calculating the error? For each data, you will find out the vertical gap. So suppose this is the curve y equals to ax plus b. Then for each data, you will be finding this vertical gap, and then you will square these errors and you create the error function. And then we'll use the calculus, partial derivative with respect to a and with respect to b to get the values of a and b. So what is the error in this case? S is summation I equals to 1 to n yi minus axi minus b whole square. This is the amount of error if you consider the error parallel to y-axis. So for possible values of a and b, what will be the criteria? For minimum value of as, what is the criteria? Del s upon del a will be 0, or suppose you are considering the line y equals to a plus bx. Y equals to a plus bx. Let us make it y equals to a plus b into x. So here there will be a little change. A minus bxi. A minus bxi. Okay. So what will be del s upon del a equals to 0? What will be del s upon del a equals to 0? You know the normal equations. By performing partial derivative with respect to a and b, you will get normal equation. So what will be the normal equation in this case? Del s upon del a equals to 0. That will give you n into a plus b into summation
xi equal to
xi equals to
summation
yi. Okay, and what will be the second normal equation? Del s upon del b equals to 0. That will give you a into summation xi plus b into summation xi square equals to summation xi yi. So you have to solve these two equations to get line of regression of y on x. In this case, what you have done, you have assumed that x value is correct, y value is incorrect. So you are measuring the error parallel to y-axis. So you solve these to get the value of a and b. Solve these to get the value of a and b. Now, some little bit of manipulation is there. I'll share you the lecture note. I'll give you the study material. I'm not going to write line by line. If you do not understand from the study material which I'm going to provide, you tell me, I will show you the calculation line by line. So ultimately, you will get the values of a and b as follows. A will be, so if you solve for a and b, you will get a equals to just a moment, y equals to a plus bx. So a will be y bar minus rxy by sigma x square into x bar. This will be coming as A, and B will be rxy by s sigma x square. Just a moment. क्या हुआ? काम नहीं कर रहे. It will be coming sigma x square. So what will be the line of regression? Line of regression of y on x will be of y on x will be what? Y minus y bar equals to, you calculate, you substitute the value of a and b and you simplify. Once you get the value of a and b, you substitute in y equals to a plus bx. So substitute the value of a and b in y equals to bx and rewrite it. So you will get y on x will be y minus y bar equals to rxy no, it is a cob xy. Cob xy. These are cob xy. These are cob xy. This is cob xy, and this is also cob xy. This is also cob xy. So your equation will be rxy by rxy into s sigma y by sigma x, sigma y by sigma x into x minus x bar. It is not, you do not have to show this much calculation. You only solve for a and b from this equation and find out the regression line of y on x. आपको ये सारे कैलकुलेशन करने की जरूरत नहीं है. We are finding a particular relationship. For that we are representing the value of a and b in this way. You will get simply two equations with two unknowns. You have to solve it by elimination method or any other method you know. So that is very easy to solve that. So the line of regression of y on x will be coming, y minus y bar will be rxy into sigma y by sigma x. Similarly, if you calculate the error, you assume that the equation is ax equals to a plus by. You assume that this is the line which represents the two-dimensional data in most suitable way. X equals to a plus by. So what you are basically assuming? You are assuming that y value is correct and x value is depending on y. So how do you calculate the total error? It will be, for each data point you have to calculate the error parallel to x axis. So it will be xi minus a minus byi square. This will be regression line of x on y. Regression line of x on y. You are assuming y value to be correct, and then you are considering x equals to a plus by. That is the most suitable linear line which is representing linear curve representing the data. So total error s will be then I equals to 1 to n xi minus a minus bi whole square. So you have to find out a and b from these two equations. So what will be del S upon del A equals to 0. That will give you total number of data into A plus B into summation yi, that will be summation xi, and del S upon del B equals to 0, that will give you A into summation yi plus B into summation yi square equals to summation xi yi. So you have to solve these two normal equations. These are the normal equations. You solve these two equations and find out the value of A and B. Once you find out the value of A and B, you substitute that value of A and B in this equation x equals to A plus by. Then the regression line of x on y will be what it will be? It will be x minus x bar, that will be equals to r into sigma x by sigma y into y minus y bar. Okay, so this will be the regression line. So let me, this is capital B and another regression line was here, capital A. So capital A and capital B, these are the two regression lines. These are the two regression lines for two-dimensional data. Y minus y bar equals to rxy into sigma y by sigma x minus x bar, and x minus x bar equals to rxy into sigma x by sigma y, y minus y bar. So दोनों की slope, हाँ? So what? So if you, in short, if you represent it by bxy, you basically, this line is regression line of x on y, so that is bxy. This is the coefficient. So x minus x bar will be, or I do not want to make it any more complicated. We leave it there, A and B. So these are the two line of regression. Now, what will be the angle between these two lines? What will be the angle between these two lines? So what is the slope for A? What is the slope for A? Regression line of y on x. What is the slope? M1 for regression line A.
rxy dot
Rxy
sigma
into sigma
s.
y by sigma x. Rxy, so slope for line A is, slope for line A is M1 equals to slope. M1 equals to Rxy into sigma y by sigma x. Sigma y by sigma x. And what is the slope of second line? B. Slope of first line, slope. Tell me the slopes. For second line, what is the slope? 1 by r xy into sigma y by
sigma x.
sigma x. So that is the slope of second line. So what is the angle between these two lines? What is the angle between these two lines? So what is the formula you know? If m1, m2 are slope of two lines, what is the angle between them? Tan theta equals to m1 minus m2 by
1 plus m1 m2.
So that is the angle between two lines. Tan theta, theta is the angle between two lines. Then tan theta equals to m1 minus m2 by 1 plus m1 m2. Yes or no? So now you substitute the values of m1 and m2 and simplify. It is very easy. You know the values of m1 and m2. Only have to submit the values of a and b. So ultimately you will come up with this expression: 1 minus rxy square by rxy into sigma x sigma y by sigma x square plus sigma y square. Nothing is there, simple calculation. You substitute the value of M1 and M2 and you simplify it. So that is the formula to find out the angle between two line of regression. Let me write down one more time. So tan theta is equals to sigma x, first part is 1 minus rxy square, 1 minus rxy square by rxy into sigma x sigma y square by sigma x square plus sigma y square. Okay. So what do you know? When the line of regression will be 0, when the angle between two line of regression will be 0, that means they will be coinciding. When the angle between two line of regression will be 0, tan theta कब 0 होंगे? Sigma x sigma y, they are two real numbers. So when that will be 0? If this part is 0, 1 minus rxy square equals to 0. What does it mean by that? So you are getting, if r equals to plus minus 1, then if r equals to plus minus 1 rxy, the correlation coefficient of the two dimensional values, two dimensional data is plus minus 1, then what is tan theta? 0? Yes or no? So
Yes,
what
sir.
does it mean by that? Two line of regressions are coinciding. Two line of regression are coinciding. तो coinciding मतलब क्या हुआ? Coincide कर गए मतलब there is a strong relationship between x and y. दो अलग अलग लाइन नहीं है, बस एक ही लाइन है जो रिलेशनशिप को एक्सप्रेस करते हैं. So what does mean by that? What does mean by that? That x y data, these two dimensional data are strongly related. Yes or no? दो अलग अलग लाइन नहीं मिल रहे हैं आपको, एक सिंगल लाइन मिल रहे हैं. So what does mean by that? They are strongly related. The data values are strongly related. इसलिए ना आपको एक ही लाइन मिला. Okay. So data points are strongly related. Data points are strongly related. And actually today I am planning to finish the lecture. और कुछ नहीं है. So what will happen if rxy is 0? What will happen if r is 0? If r is 0, rxy is 0, what will happen?
Then it will be infinite, tan theta equal to infinite.
So tan theta is infinite. So what does it mean by that? Theta equals to
Pi by 2.
pi by 2. That means two line of regression are intersecting perpendicularly. Two line of regression are intersecting perpendicularly. Okay. So if r is 0, that very little relationship is there. If r is 0, what does it mean by that? The data points are evenly distributed around the mean position. If rxy equals to 0, data points are evenly distributed about the mean values, x bar, y bar. So no relationship between x and y values are there. So two line of regressions are intersecting perpendicularly. और अगर कुछ और वैल्यू होते हैं तो you will be getting two line of regression and they will be making acute angle. Okay, so this is the syllabus. So I'll give one more problem here and you have to find out. So let me give you a set of data points. Suppose that is representing some physical phenomena. So suppose you have these data sets. So calculate. So exercise. Calculate the coefficient of correlation. Calculate the coefficient of correlation and obtain the line of regression for the following data, and obtain the line of regression for the following data. Okay, they are representing certain natural problem. These data points are collected that way. So x and y, they are given in this way. 9 data points are given: 1, 2, 3, 4, 5, 6, 7, 8, 9, and corresponding y values are given to you: 9, 8, 10, 12, 10, 12, 11, 13, 9, 8, 10, 12, 11, 13, 14, 16 and 15. 16 and 15. So what is the correlation coefficient? How much these data points are related to each other? So find out Rxy. Also find out the line of regression on x on y and y on x. So let me tell you the answers. It is up to you. Huh? So answers. You know, I have already discussed the method. So answers. Rxy will be coming 0.95, 0.95, and two line of regressions will be a line of regression of y on x will be of y on x, that will be y minus 12 equals to 0.95 into x minus 5. That is the line of regression of y on x, and line of regression of x on y will be line of regression of x on y will be given by x minus 5 equals to 0.95 into y minus 12. So these are the two lines of regressions, and this is the correlation coefficient. So if you see how these data points are related, so you take a graph paper and you plot this data, and then you plot these two lines, and you will see how why you are getting two such lines. Okay, so I will stop the discussion at this point. So this is about it. This syllabus for numerical methods and statistical technique. In last unit, we have discussed what we have discussed. We have discussed probability density functions. We have seen some example of probability density functions, continuous and discrete. We have seen some practical problems can be modeled in terms of probability density function. And then we have studied regression analysis. Okay. So anything you want to ask? Students?